Okay, we're moving on to our second part of direct variation. Your learning target, you can still identify proportional relationships, and you're going to be able to determine the constant of variation. I want you to keep in mind that direct variation means y equals something times x. That something we have learned is really the slope. Don't you agree? Y equals mx plus b. The only difference between these two is b cannot be 0 for a normal line. Here, we have a y-intercept of 0. So that's why they separate the m and the k. M means that I can cross the y-axis anywhere. K means I'm only crossing it at 0. Okay? So direct variation means it goes through the origin. That's the middle number, isn't it? Don't you remember? Okay. Now, is this line, does it go through the origin? No. So it's no. It's not it's not directly proportional. Is the next one directly proportional?
Yes.
Yes, because it goes through the origin. Okay, is the next one directly proportional?
No.
No, because it didn't go through the origin. Remember, it's quick. Do you go through the origin or not? You say yes or no. That's all you have to do. Is this one directly proportional?
Yes.
Yes, because it goes through the origin. So our learning target, with given a graph, you need to be able to figure out, does it go through the middle number or not? Okay, that's fun. Let's go to the next one. I want you, under the heading, to write y equals kx. You have to, no choice. Y equals kx. That means constant or directly proportional relationship. Directly proportional, let me dissect that. Directly means it's going right to that number. Proportional means it's a constant like slope. Okay? So this is our slope, and it is also our constant of variation. They are the same thing. A slope, you are constantly changing. Do you agree with that statement? Mm-hmm. Slope is a constant. Rise over run, rise over run, rise over run. Constantly varying. They are the same exact thing. So constant of variation is y over x. It's how your y changes over how your x changes. Yes? So cloud that, y over x. That is the heart of today. If you can recall that any directly proportional relationship is representing slope, y equals something times x, that something is always y over x. Rise over run. So here's what you're going to do. Identify the constant of variation first, and get into direct variation form. I'm going to show you two ways to do this. Two ways. And you're going to tell me which way you like better. I'm going to do normal algebra. Some of you are algebra lovers. You could do algebra all day long. Okay? This is what I know. Y, don't write this down. I want to show you both ways and you choose your favorite. Y equals something times x. Do you agree that's the equation? Okay? That's my x. That's my y. X goes here. Y goes there. 7 equals 4k. I did that because I wanted the number first. Solve for k. 7 over 4 equals k. Get back into this form. Y equals 7 over 4x. I'm not a big fan of that. It's how I used to always teach it. And then I decided this year, I think I'm just going to teach you the trick. Some kids just want to get to the trick right away. Remember that k is always going to be y over x, okay? K is always y over x. Do you agree with that? Change in y over change in x. So x, y, k would equal y over x, which is 7 over 4. Y equals 7 over 4x. Okay? Here, y equals kx. K is equal to whatever y over x is. What's y?
12.
What's x? Put it in an equation. Y equals 12 over 5x. So again, this is the heart. This is the real algebra behind it. This is the trick. K equals y over x. Do we have that somewhere? Maybe, well, right here. Maybe you could do it in between. You could say k equals y over x somewhere. Okay, what's y? Tell me, what's y?
6.
Over what's x?
10.
Okay, 3 over 5?
Yep.
So y equals 3 over 5x. Okay, now we're going to find the constant of variation and create an equation from a table. Remember, a table, actually, I'm not even going to tell you. All you're going to do is pick a point. Pick a point. Find your constant. So your constant of variation. Anybody remember what is k? K equals y over x. So you're just going to put y, put it over x, and then call it good. You can't use the point 0, 0, just so you know. There's no way. There's no way. You can't do 0 over 0. So you can't.
Oh, no, you can't.
Yeah. So you're going to have to pick another point. So I'm going to go ahead and pick my first point, 10 and 4. Notice how I did that? You could pick any of them. They will simplify to the same thing. K is equal to y over x, 4 over 10, 2 over 5. Y equals 2 over 5x. What's the slope of that line? What's the slope? Up 2 over 5. Where do I intersect the y-axis at? Yeah, if it's directly proportional, it has to be 0. So this is the slope. This is the y-end. You will have to graph direct variation today. It doesn't give you 0. You just need to know it's 0. Okay, you do the next one and then compare with someone next to you. Okay, so again, step 1, according to my notes, is pick a point. So I'm going to do it. I'm going to pick a point. It can't be 0, 0, so I'll have to pick 2 and 3. And then it says find my k, or my constant of variation. K is equal to y over x, which is 3 over 2. So y, just throw it into the equation. Y equals 3 over 2x. If I were to graph this, the y-intercept is 0, and the slope is 3 over 2. Up 3 over 2.